Long, long ago in the far distant past, around 540 million years ago, during the Cambrian period in the ancient Earth's oceans, creatures shaped like this emerged into the world. That's right, they became widely known as trilobites. When they are divided lengthwise, we can see three parts, the axial lobe and two pleural lobes on each side. Many people believe that this animal is a single species. In fact, trilobites is a collective term for arthropods that belong to the trilobite class. There are over 20,000 types in the trilobite class, each type bearing different appearances. Most of the trilobites are only a few centimeters in size. However, specimens over 50 centimeters in length are occasionally discovered. Trilobite's exoskeleton is made of calcium carbonate, which is suitable for protecting its body. Trilobites are not as simple a species as you may think, since they have digestive systems and well-developed eyes. Most notably, the compound eyes of trilobites, which appeared on Earth almost for the first time, were well suited for searching for food and avoiding predators. And interestingly, most animal eyes are too soft to fossilize. However, the trilobite's eyes are made of calcite, which leaves behind fossilized remains of their distinct compound eye structure. What was the world like as reflected in their eyes hundreds of millions of years ago? Considering the characteristics of calcite, which exhibits bifringence, it might seem that the vision of trilobites was blurry due to overlapping perspectives. However, many paleontologists now speculate that the single eyes of trilobites were intricately arranged to compensate for the bifringence, allowing them to see the world more clearly than initially thought. Trilobites, equipped with remarkably sophisticated visual organs, thrived in various depths, ranging from shallow coastlines to continental shelves. They inhabited regions across the globe, from China, Siberia, Europe, and America, to Australia and even Antarctica. Incredibly, this spanned over 300 million years. However, around 251 million years ago, after enduring the test of time for 300 million years, trilobites completely disappeared from the Earth. Why did such a flourishing organism vanish? How did it follow the path to extinction? Or was it a sudden event that sent the trilobites into oblivion? Now, let's get started with the story of the trilobites' extinction. Actually, there needs to be more than one event for a creature as fascinating as the trilobite to go extinct. Multiple incidents are required. The first trial that befell trilobites occurred 440 million years ago, at the end of the Ordovician period. At that time, the Earth was entering into an ice age. Trilobites, which inhabited warmer seas, were adversely affected by the sudden drop in water temperature. What's more, as the seawater froze and sea levels dropped, trilobites living in shallow waters lost their habitats, and then they were driven to extinction. In fact, the Great Ice Age wasn't just devastating for the trilobites. It was so severe that it led to the extinction of 80% of marine species. This time is known as the Great Ordovician Extinction Event. Dr. Samuel, an ecologist, revealed that the number of trilobite families, which had reached 42 at the time, was nearly halved due to this mass extinction level event. On the other hand, one hypothesis suggests that the emergence of jawed fish 440 million years ago was one causal factor behind sharp decrease in the number of trilobites. During that time, it was evidenced that a large number of trilobites appeared armed with sharp spikes to defend itself against predators. However, in actuality, this evidence alone was insufficient to directly associate the emergence of predators with the significant decline of trilobites. In any case, trilobites survived even after the mass extinction level event of the Ordovician period. Richard Forte, a paleontologist at the Natural History Museum in London, wrote in his book, Trilobite: Eyewitness to Evolution, that after the Ice Age, a variety of trilobites gradually regained their diversity. This included the diamantid trilobites that lived in cold water, the Phacopeda trilobites with developed eyes, trilobites with bumps on their heads, and those that could roll up their bodies like modern woodlice. Such diversity seemed to carry trilobites safely through the Silurian period and into the Devonian period. However, another trial came upon trilobites toward the end of the Devonian period. This was the late Devonian mass extinction level event, also known as the Frasnian-Famennian boundary event. This mass extinction, which occurred 370 million years ago, caused more damage to the marine environment than to the land-based environments. Dr. Thomas Algeo, a geologist, analyzed the marine strata from the end of the Devonian period. He found that for some reason, whether it was due to a meteorite collision, a volcanic eruption, or something else, one thing was certain. The amount of oxygen in the ocean had drastically decreased over a period of 20 million years. In other words, due to oxygen deficiency, most marine life at the time, including trilobites and coral reefs, went extinct. To illustrate how severe the hypoxia was, the trilobite family, which had over 10 species, dwindled to only 4 to 5 species after the Devonian period. Trilobites, which flourished with over 60 families in the late Cambrian period, saw their glorious era disappear without a trace by the end of the Devonian period, gradually descending into ultimate decline. Due to trilobites' remarkable prosperity, Proatida trilobites managed to survive the Devonian period and continue to exist until the late Paleozoic era, through the Carboniferous period and into the late Permian period. They were the true survivors, appearing at the end of the Cambrian period, overcoming various difficulties to survive until the Permian period. However, 251 million years ago, the worst mass extinction level event in history, known as the Permian mass extinction, dealt the final blow to these last remaining trilobites. In the face of an event that wiped out 95% of marine species and 70% of terrestrial vertebrates, even the resilient trilobites were tragically wiped out. Currently, the most likely cause of the mass extinction in the Permian period is believed to be a massive volcanic eruption that occurred in the Siberian region. To give an idea of the magnitude of this eruption, Dr. Alexei Ivanov, who studied the eruption in 2013, stated that the volcanic output reached 4 million cubic kilometers. This is enough to cover the entire United States with a layer approximately 400 meters thick, and there would still be some left over. So, how did this mass explosion lead to the extinction of the trilobites? In 2018, a paper detailing the specific process of the Permian mass extinction was published in the journal Science. The research team's argument states the following. At the end of the Permian period, an unprecedented massive volcanic eruption occurred in what is now Siberia. As the volcanic ejecta penetrated the layers of coal that had accumulated during the Carboniferous period, it burned the coal and began to release massive amounts of carbon dioxide and methane into the atmosphere. These greenhouse gases brought about severe global warming, leading to a rapid rise in water temperature. At that time, the water temperature near the surface of Pangaea, which had become a supercontinent, increased by nearly 10 degrees Celsius. The problem started precisely from this point. The warming of the seawater accelerated the metabolism of marine life, including trilobites. However, conversely, as the water temperature rose, the amount of dissolved oxygen in the seawater decreased. As a result, marine life, with their heightened metabolic rates, suffocated due to lack of oxygen. The research team added that other factors that emerged later, such as acid rain and ocean acidification, also hastened the extinction of organisms. Probably the only choices left to the trilobites of that time were to die, or to die. In this way, trilobites, which roamed the Earth's seas for over 300 million years, experienced 3 major extinction events and eventually disappeared into a historical abyss. Now, they present themselves before us as robust stones bearing the marks of Earth's mass extinction events. Science is a window to the world, and this has been Science Dream. Thank you for watching.